Hi there. Welcome once again to another fantastic and interesting topic. Now, the mathematics topic before us today is just the inverse function, right? Inverse function. The inverse function, inverse function, right? So how do you play with the inverse function? How do you play around with it? So that's what we're going to be discussing today, right? The inverse function. Now, when you talk about inverse, you're talking about having to do with the concept of your domain and range, then taking the inverse of the entire function, right? Does it make sense? You have a function. Remember, our function is always in terms of x. And I told you guys before now that this is actually our y, right? So we have the dependent variable and then the independent variable. Now you're giving the idea is that we're giving the function always in terms of x, for instance, 2x plus 1. And then we say this is our f of x. So the inverse of a function, the notation for that mathematically is the inverse of this function. So what is actually the inverse of the function? So that's what we're going to be discussing in this particular video. By the end of this video, you're going to be learning how to change your function to its inverse. Then you have to know the concept of domain and range. If you have not gotten that already, you can please check the videos in the description down below here, or you can just follow through with me so that you get everything you need to know. Now, for example, if you have this function over here, what is the inverse, right? I have this function, x squared. So what is the inverse? This is f of x, right? So what is the inverse of this function, right? What are the inverses? So that is what we're going to be discussing today. Now, simply, the inverse of a function is just very easy to get. If I have my x, my y to be equal to this function f of x, so the step I need to do right now is I'm going to switch. I'm going to do what? I'm going to switch x and y around. So if I switch x and y around, and I will now solve, I will solve for y, right? Then what I'm going to get is now going to be the inverse of the function. Now, this sentence is too long. The only thing you can get from here is that switch x and y in the original function, switch the value of x and y in the original function, and solve for y. Then you're going to get the inverse. So for instance, if I take this particular function down here, I have my y, I have 2x plus 1. This is my original function, f of x. Good. Switch x and y. So simply, instead of y, I'm going to put x, right, is equal to 2. Instead of x, I'm going to put y plus 1, plus 1. Fantastic. So I have done the first step over here. So all I need to do next is what? I will solve for y. So over here, by simple algebra, I'm going to take 1 over here to the other side. I'm going to collect like terms. I have x minus 1 is equal to 2y. I did what? I just collected like terms over here. So what am I going to do next? I'm going to divide 2 by the coefficient of y. So I have x minus 1 over 2 is the same thing as 2y upon 2. So Basically, I'm going to get y is equal to x minus 1 upon 2. And this is what we have as the inverse of this particular function. How cool is this? How simple is this? Straightforward. Remember, if you have not liked this channel, you should do that right now. And then you can subscribe to this channel. Fantastic. So we're going to be looking at some other examples, but for now, what can we say about the range of this function as regards the inverse of the function? So we can say that the range, remember what is the range? This is the output, right, of a function. Now, the output of a function, right, now it will be the domain, right? It will be the domain of the inverse of this inverse function. Isn't that cool? From that example we saw, you can verify that. Now, similarly, the domain of f of x will be the what? The range of what? F inverse of x. Isn't that cool? Isn't that fantastic? Good. So it's unique. So let's see if we can take some other example. I have a very fine example over here. X is equal to 2 upon 3, x plus 7. This is our f of x. So find the inverse of this function. First step one is what? Remember, you switch x 2 upon 3y plus 7. Step one, check. Solve for x. Solve for y, rather. Solve for y, like make y the subject of the formula. So if I'm solving here, I have, what can I do over here? What can I do over here? I can decide to take this to the other side by collecting like them. I have x, taking the other side, I'm going to get x minus 7. This should be equal to 2 upon 3 of y, right? I think this is fantastic. So what am I going to get next? I'm going to get x minus 7, right? This is going to be multiplying 3 because I'm going to cross multiply. Then automatically my 2 is going to be here, 2y. So if I divide both sides by 2, I'm going to be getting 3x multiplying this minus 21 over 2. And this is canceling out. So my y is now equal to 3x minus 21 upon 2. So this becomes the inverse of what? Of x. How cool is this? How cool is this? Let's take some other example. Let's take some other example if we can. If we can, we have very straight. Y is equal to minus 2 upon x plus 5. First step, switch. I want to get the inverse, switch. I have x is equal to minus 2 upon y plus 5. I have done the switching, right? I have switched this particular guy over here. So can now cross multiply. I have x into y plus 5, right, is equal to minus 2. And here I can have x, y is plus 5, x is equal to minus 2, which I can take whatever, I can take minus 2 minus 5x, right? I can take it to that side I'm going to have y is equal to, what can I get again? Minus 2 minus 5x upon x, right? This is cool. This is straightforward and cool, right? So my y is this guy over here. So I can say it's 2 by x. Then here I have just minus 5. This becomes our f prime of x. How cool is this? This is so cool. This is cool. Now I can have so many examples. I have, lastly, let's just take this one. Y is equal to x minus 1. Then you have upon x plus 3. Switch x and y. So I'm going to get x is equal to y minus 1 upon y minus plus 3. Cross multiplying, I'm going to get x into y plus 3 is equal to y minus 1. So I have xy plus 3x is equal to y minus 1. If I am collecting like terms over here, I'm going to have xy minus y is equal to minus 1 minus 3x. I can factor out y. I'll be left with x minus 1 is equal to minus 1 minus 3x. I can divide both sides by x minus 1. So I have x minus 1. So this is going to go with this, and automatically this become my f prime of x. How cool is this? Now remember, in our denominator, right, we consider the denominator when we're dealing with function. At this point, you remember, for this function to be defined, x here, the denominator cannot be 0. So it's everything except minus 5. So minus 5 is not going to be in the domain of this particular function. So when you consider the inverse, right? So the inverse, you're considering the inverse right now. We cannot have, we can have 0. And we have 0 over here. This become undefined. So we cannot have 0 in the denominator, right? We cannot have 0 in the denominator here because we're going to be having undefined elements here. Considering this one also, x minus 1 can never be 0, right? Good. Here, x can never be minus 3. So that is how to check. You have to check where the domain of the function is what is defined. You have to always consider, check where the function is always defined. When you have a radical in the denominator, then this element here must not be less than 0, right? We can have 0 under in the denominator, but it cannot be negative, right? If it is negative, we have gone to what we have discussed in this video, the complex number, right? So when you're talking about the domain and you find out you have a radical, you have the square root sign in the denominator, the value over here should be greater than or equal to 0, right? When it is just a polynomial or a fraction, consider it should be what? It should not be 0. This can be 0, but should be greater than 0. Should not be less than 0. Thank you for watching this video. Remember, if you have not, please subscribe. And you should do well to give a like, comment, and share this video. See you in the next video, and thanks for watching.